So many handouts. Ants, okay. This one, no. This one, no. This one, yes, okay. So I've got a tough trough problem. I'm gonna do this together real quick. On the other side is kind of related to what we're gonna do next. By the way, I want to apologize in advance. They're not, the front and backs of these are not necessarily the order we're going to do them in, so I'll just deal with that. So the tough trough problems, look at that one. Tough trough problem. So it's always nice to have a computer generate a picture for you. It's much better than me trying to draw it. So the very first thing I ask in this problem is verify that this is the volume. So, does someone remember the volume formula for any repeated shape? Something about, say again? Yeah, the volume for any repeated shape would be the area of the face times the height or the length. In this case, I'll say length since it's laying down. And the great thing is, what's the length of this? Does it change? As the water level goes down, the length is 7. So any repeated shape. So if I have a circle and I repeat it, or if I have a triangle and I repeat it, or if I have a trapezoid, I repeat it, it's the area of the face of it times how long it's repeated for. That's the volume. It's kind of crazy. So already we know L is always 7, yeah? So now my problem becomes, what's the area of the water face? So what is the area of this little blue triangle face there?
1/2.
Yeah, what's the base? I'll tell you over here, but W. And of course the height, crazy enough, is H. I like it. Okay. Is everybody with me? And again, what's most important on a problem like this is what made me take the steps I did. This wants me to figure out the volume, so let me write the volume formula. Let me start to figure out the parts of it. Okay, now I can focus on the area of this. What's wrong between what I've got so far and what I know the answer is supposed to be? There's not supposed to be a what? There's not supposed to be a W. So now I got to figure out, is there a relationship between W and H? So that I can rewrite it without a W. So this triangle, here, you go down. Holy shit. Okay. This triangle versus, the big triangle kicks ass, yes? Is there any dimension I don't know of the big triangle? No. The big triangle, thank you, you're so awesome. But the stupid triangle that represents my actual water sucks. Well, what kind of triangles are these? Similar. What does that mean? Proportions are the same. So what I like to do normally is like small to big. Don't H and 10, don't they both measure the same aspect of the triangle? So H is to 10 as W is to 4. What letter do I want gone?
W.
So I want to solve this for W so that when I replace it, it's gone. Yes.
Why do you want W gone?
Because I know I want the answer to be in this form.
Okay.
And W is in my way. I could have just said, write the volume in terms of height and not given you the answer. And you would still want the W gone because I want it only in terms of height. So how do I solve this for W?
Times 4.
Yeah, if I multiply by 4, yeah? And of course, what does that reduce to be? 2h over 5. So now if I plug this in here, I'll get the area. Is that cool? I just replaced W with what it is. The 2's cancel. This makes h squared over 5. And now this, I can plug in over here. So now I know my volume is 7h squared over 5. Yeah? Just multiply that by 7.
We see you at the end.
So again,
You zoom out, please. Thank you.
this is the kind of progression you need to be able to do. So how did I do it? They're asking me for volume, so I wrote the volume formula. Then I said, okay, what do I know the length is 7, kick-ass. Now I can focus on the thing I don't know. I can focus on it. Oh shit, I don't want W. Okay, what else do I know? Similar triangles, okay. But it's not guessing, I write there it is, there's the formula for what they want. These crazy ass people. And then I say, okay, do I know anything? Okay, good, I know the length. I don't know the area. Oh shit, let me focus on that piece. Let me create that. Oh shit, there's more letters than I want. Okay, let me focus on that. It's a clear distinction of, okay, right now you want to do this, so then you can plug that in there. Okay, maybe. This is the skill that I completely understand you guys have not gotten enough practice with. This is a skill we would focus on in intermediate algebra, for example, when it existed. Pre-calculus, which maybe you haven't taken in years. Okay. Everybody okay so far? The mistake a lot of you guys make is you pay way too much attention to this too early. And you try to force it to, no, it just should happen. All right, now part B. Is there any calculus involved in part B? Do we have a volume formula? Yes. And what's this problem asking me for?
For height.
What does this problem ask me for? Volume. And it's telling me what the height is, yes? So how do I figure that out?
Plug in.
Plug a frickin' 2 in, yeah, you gotta love that shit. Okay, so let that one be easy. Don't assume every problem's gonna be hard. So then 7 times 2 squared.
28 over 5, right?
Yeah. Anybody know the trick to divide by 5? Besides push the buttons on your calculator? What's 28 doubled? Okay, well. 56. Now move the decimal back 1. 5.6. If I double the top and bottom, what's the bottom become? 10. Divided by 10, you just move the decimal back 1. So if you want to divide by 5, you double the top, and you move the decimal back 1. Or you go, Joe, I have a calculator? Okay, whatever. I'm not saying that's how you sound, but maybe it is how you sound. I don't know you. And what's the units on this? Cubic meters. I like it. All right. And then part C, same idea, right? So let's just do this real quick. I want it when it's 2.3. Whatever the hell 2.3 squared is. 5.2, 5.29. Sorry. So you get 7 times 5.29 is something. 36 point. What is it? 37.03. So if I double this, I get 74.06, and I move the decimal back 1, I get 7.406. Somebody can double check if I did that right in my head.
7.46.
Yay! Real quick, how much did the volume change?
Two?
Not quite 2, yeah? Almost 2, like 1.794 or 1.806, there you go. So let me stop for a minute. Those two questions kicked ass because they were just plug and chug. I have the volume formula. Great. Now what's wrong with part D? What's it asking me for? What is the question asking me for?
The rate of change.
Rate of change of?
Volume.
And what's the what's the symbols for that?
dV over dt.
Do I have a formula that has this in it? No, so there's no way in hell I can calculate this until I get a formula that has this in it. How do I do that shit? Say again? Take the derivative, yeah. Take the derivative. So real quick, on the problem on the test. Maybe this doesn't relate as much as I thought it did, but do you see how we had to come up with a relationship between W and H? On the test, didn't I tell you the radius is 1/4 the height? I just told you that shit. You just had to plug that in. Where you saw an R, you just had to put a 1/4 H. Square it. What does that do for you? Well, now I don't have to do product rule for it. If I took the derivative with W and H, that would be product rule. Then I need to know what dW dt is. And I don't know that shit. You guys sort of? If your formula has more than one variable in it, most often we want to get rid of one of them. Do I tell you anything about how the width is changing? What do I tell you? So I ask you this, and I tell you dH dt is 0.3, careful. And I tell you at a time when H is 2.15. Yeah. So another mistake people made was they plugged that in too early. If I plug that in, I'm going to get a number. What's the derivative of any number? Okay, that sucks. So I cannot plug the snapshot in until I've taken a derivative. Because this is changing over time. What is the derivative of this? I'll do this side. Okay. 14 times? Good, dH dt. Because I have to take the derivative of the inside function, right? And now I have, for example, if you didn't have that, you'd have nowhere to put freaking 0.3. So that would be sort of a clue. So now I just got to put stuff in the right place. Let's see. What do I put here?
2.15.
2.15, and what do I put here? 0.3.
The units are wrong for that.
Why is that?
You're measuring volume, but you have meters squared for your unit.
What's 7?
Is that,
What's 7?
that's meters?
That's meters, yeah. But I appreciate that. Unit analysis is good. If you've ever taken chemistry, you know the phrase unit analysis, or physics, right? Unit analysis. Make sure that the units come out right, and if they don't, you've set up the function wrong. Yeah. You guys at all with me? Is everybody sort of with me? Screw you, Jeff? Okay. So I have a formula for volume. It relates volume and height. I want to make a formula that relates the rate of change of volume and the rate of change of height because I know the rate of change of height and I want to know the rate of change of volume. So of course I need a formula that's got those in it. How do I do that? Derivative, because they're all about derivatives. Then I can plug shit in. And then I get whatever the hell that is. I don't know.
1.806.
1.806? Now, what would the units be?
Meters.
Per second. I love it. What's special about, okay, let me see if you guys are cool with this last thing. What's special about 2.15 compared to the things we did here? This was 2 meters, this is 2.3 meters. 2.15 is directly in the middle. So the tangent line at 2.15 can be approximated by the secant line around it. So basically, so if I pick a number between those two, in fact, look, I predict the volume should change by about 1.8. How much did the volume change? In fact, I predict it's going to change by 1.806. Exactly how much did the volume change by? 1.806. And by the way, real quick, how much did the height change from here to here? 0.3 meters. And how much did I say it was changing per second? So how much time was between these two? 1 frickin' second. And I say the volume is changing by 1.806 meter cubed per second. So our actual physical measurements match up with our prediction, which is, always nice. Can you do this with every problem? You could. Should you? Probably not. You don't have that time for that. But so this last one says find the difference, and it is 1.806. Compare it to that same. What do you observe and why? They're the freaking same, Jeff, because one is a prediction and one is what actually happened. All right. Okay. So a decent number of the problems in that section 3, was it 3.9? Related rates, yeah. What we're about to get into today, and one reason why I didn't mind doing this is because there's no way to say this otherwise. We're getting into the other word problems for calculus, which is optimization problems. You did optimization problems in pre-calculus. So you've done problems where it came out to be a parabola, and if it said find the maximum, where would that be? Vertex. Does anyone remember the shortcut formula for finding the vertex? So if I know I have a function like this, does anyone remember the shortcut formula for the vertex? Negative b over 2a. Does that sound familiar to anybody? Very quickly, I'm going to take you through the shit, because that's what I do. If I knew the x-intercepts for a parabola, where's the vertex? Where's the x part of the vertex going to be? I know the x-intercepts.
In between.
It's going to be right in the middle, yes? Because it's symmetric. How do I find the x-intercepts for something like this if I can't factor it? Quadratic formula, right? So it'd be negative b plus or minus square root of b squared minus 4ac all over 2a, blah, 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 right? You with me? Isn't this negative b over 2a plus or minus shit? If I break it up, is everybody with me? If I break this up, isn't this negative b over 2a plus or minus stuff? This gives me the intercepts. So if I add, I get this one. If I subtract, I get this one. So of course, what's right in the middle? What's right in the middle? What has to be right in the frickin' middle? Negative b over 2a, because I added stuff to it and I subtracted stuff from it. So of course the middle is negative b over 2a. That is the way you did it in pre-calc. We're better than that shit. We know calculus, right? What is shit? So where is the vertex going to be? What's going to be true at the vertex, calculus-wise? Slope is 0. So if I have this function, how do I find where its horizontal tangent line? Derivative. What's the derivative of this? 2ax plus b. Set that equal to 0. What do you get? Subtract b, divide by 2. What the shit? Alright, sorry. You get the same. Of course you do. So in pre-calculus, you could do some kind of manipulation, understand that this kind of gives you the middle already. We can kind of figure out what the middle is. Calculus, we can get there much easier. Because we know at the horizontal tangent line, it's got to be 0 slope. That's what's going to happen at the min or the max, so I can just get it. Okay, maybe. So that's the kind of optimization problems you guys did. You found the vertex. Profit function, you found the vertex, you said you had to sell this many widgets to make the most money. Yes, yes. You did that in pre-calc. Last semester or 8 years ago, whatever it is. So, what we're about to get into, and this is section 4.7, by the way. 4.7 is optimization of all kinds of functions, not just parabolic. Because we now know how to find the max and min no matter what the function looks like. So with optimization, it's all about take the problem, set up the function, get a derivative, set it equal to 0. It's going to be wash, rinse, repeat, right? So what's the hardest part of the whole process is going to be is setting up the function. I think we all would agree. Once you get a function, can you guys take the derivative? Yes, you can just eat that up. But it's just getting the function set up that sucks. So what I want to do is I'm going to take some baby steps. I'm going to give you a handout. That kind of sucks. Don't worry about, only worry about this side. This is 4.8. We're going to get there later. So there's one side that says word problems handout. I'm going to do that one right now. Alright guys, let's take a look at this. So this is, yeah? One more? I can't write, I can't count, so I became a math teacher. Alright, so I gave one example. And this is basically how to set up a word problem. The people that skip a step are the ones that make mistakes. The heart of a word problem is translating from English to Mathish. Right? Math is a foreign language. So this is already done. But you guys see what's the most important thing? The very first thing is use the same language to identify the parts. When I say what are the players, what are involved in this problem, there are 3 sides. That's what's involved, correct? And I'm going to use the same names that the problem did. If it said first side, second side, third side, I'm saying that shit so that I can directly connect them. What is the most important step here? I probably pretty much give it away, but do you see how one side determines the other two? Like there's two of the sides depend on the third side. Yes? You guys see that? Which side do I have to know first? Because then it can build to become the other ones. Which side? I'm sorry, I think shortest. Yes? Real quick, look. The largest side is blah as the shortest. The middle side is blah, the shortest. Don't I have to know the shortest first? And then I can calculate what the other two are. So the weird shit with algebra is, I know the parts. I have to give them names so I can do stuff to them. I can't do blank space plus twice blank space. No, I need to give them names so I can actually work with them. If I call the shortest side X, I now know what the hell to call the largest side, not frickin' Y, because the largest side is dependent on the shortest side. So do you guys agree with what I wrote there? Largest side is 3 times as large as the shortest. We call the shortest side X. So of course the largest side is 3x. Okay, I like it. And of course the middle side is 1, okay, this word sucks. 1 less than twice the shortest is not 1 minus 2x. What's 1 less than 11? How did you get that? What math did you do? 11 minus 1, it turns around. Whose fault is that? English? English sucks. It's not math's fault. English sucks. If you grew up with English, we don't know how much English sucks. If you learn English second, you know how much English sucks. Is everybody kind of with me? Hopefully this is, I know some of you guys this is boring, that's great. Some of you guys are like, nobody's ever told me this shit before, so, okay. Identify what the parts are, what's involved, give each thing a math name based on what the problem tells you. Draw the picture, hell yeah, you're gonna be drawing a lot of pictures hopefully, or don't and make mistakes. It's up to you. Then there's gonna be something that ties all the players together. In this case, I tell you the perimeter is 23 feet, so of course if I add up all the sides, and then that's where my equation comes from. My equation comes from how are all the players connected? Or how do they work together? Okay, hopefully this is not ground shaking, but we all kind of need a refresher. Because again, some of you guys haven't taken math in a while. Some of you guys really didn't get a lot of practice with word problems before. All right, and then I give you one more that's less geometric. There's nothing to draw. You can draw a bunch of people if you want to, but it doesn't really help you. So there are 3 more than twice as many women than men. So that one's a little bit tricky. Which one do I have to know first? The men, because then I can do twice that plus 3, that's how many women were there, right? And then, same idea. Once I get math names for the English, I can set up an equation, I can solve, get all my answers, blah, blah, blah. So, real quick. Number 1 is an example of like a pseudo equation. It's already basically an equation. Do you guys see that? Can you guys write the equation this represents? As I slowly die. Killing me softly with his math. So this has got that less than thing in there, so be careful. So what is it I don't know in number 1? The number. So what do you want to call it? X. You can call it N. You can call it happy face. You can call it omega. You can call it whatever. Shit, you would just need a symbol. And X's are like fall to symbol. 6 times the number, what's that? Is equals 20 less than twice the number. Yes, twice the number is 2x, 20 less than that, you take 20 away. Then you got a stupid little equation you can solve. What do you guys get? -5, I love it. How do you check that? You can just do the English. 6 times the number, that's -30, yeah? 20 less than twice. Twice -5 is -10. 20 less than that is -30. I get the same number, yeah, and it's good. You guys kind of with me? And again, I apologize if this is all old shit, but some of us desperately need this. All right, try to do number 2. Maybe, do it on another sheet of paper. Don't just cram it all in there. All right, let's see. So we got a triangle. I got a shortest side, longest side, that's crazy sauce. Third side, yeah, I love it. So just use exactly the words that are used in the problem. Even if they're nonsensical, it doesn't matter. You want to be able to go back and forth real easy for yourself. Does anyone figure out which one I got to know first? Yeah, because everything's related to the longest. If I knew the longest, I could do some stuff to it to figure out the other 2. That is the one that is just a variable. What letter do you want to use?
X.
No way, okay. So the longest we'll call X. So what's the shortest side then?
X minus 15.
X minus 15. And what's the third side?
X minus 6.
Yeah, X minus 6. I love it. And then what ties those all together?
102.
They added
Brian,
102.
102.
Yeah, I get a perimeter of 102. And of course, perimeter is just add up all the sides. There's no perimeter formulas to ever memorize. It's just add up all the freaking sides. Perimeter kicks ass. Huh?
You do not have over?
So then I get this side plus that side equals 102. And then that's easy as shit, yes. What did I do here? Okay, good. So I get 3x minus 21 equals 102. Is everybody with me? 3x equals 123. So I get x is 41. 41 what? Feet. You circle that and you're done? Yay! You sure? Are you done?
Oh, no.
Oh,
You
shit.
have to plug it
So
in.
this is why this step kicks ass, because now I can go, that's 41 feet. What's this one?
15 less than 2.
That is so right. What's 5 less than 41? 36, and then 10 more? 26, okay. So you just do minus 15 in 2 parts, no big deal. And of course, what's this one? 35, I like it. How do you check your work?
I don't know.
Add them all up, make sure it's 102. Blah, 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 blah. Okay. Alright, so hopefully, for a decent chunk of you guys, this is not that big of a deal. Some of you guys maybe, I don't know, it's been a while maybe or something. Now real quick, I don't want to spend a ton of time on this, but look at number 3. Sorry, did anybody get that? Number 3. The most common mistake I get. Let me watch it. Here's what I see students do. So Malcolm's backyard, he would like to make it with Matt. The yard is 4 meters longer than it is wide. So the yard is 4 meters longer than it is wide. So x plus 4 equals 92. Yay! Yeah, what's wrong with that? What's wrong with that?
That's not a rectangle.
Does that represent, 92 is supposed to be the perimeter. And how many sides do I have equaling to 92?
One.
I got one side. So what this person did, they saw the algebra in the problem. Something plus 4. Okay, something plus 4. The number's 92. Yay! So they skipped the step of identifying the players. They skipped all that shit. And this is the kind of mistake you can make. So, what are the players in this problem? Wrong.
Perimeter.
Yeah, you draw a rectangle. I love it. What are the players?
They all add up to 92.
No, that's what the players do. What are the players? That is the math name for a player. What are the players? What are the parts? Length and width. I love it. Length, width. Which one's got to be just a letter? So yard is 4 meters longer than it is wide. So I need to know the width first. Are you guys with me?
Yes.
So I'm gonna call it. I'm gonna make a W just to be different. So then, what's the length?
4 W's.
Careful.
Or 4 W's.
Yeah. 4 meters longer is not 4 times as long. 4 meters longer is W plus 4. With me?
What would it be if it was times 4?
It would say 4 times as big. Yeah. If I was 4 years older than you, am I 4 times as old as you? No. So 4 meters longer, 4 years older, that's plus. Okay. Thankfully. I don't want to be 4 times as old as you. Maybe I am. Holy shit. How old are you?
19.
It doesn't matter. Okay. 19? No, I'm not quite there. Okay. Definitely. And now here's the next mistake. I'm going to make a mistake. What's wrong with that? Yeah, so if you label your picture, you won't make that kind of mistake because perimeter I've got to go all the way around. So What am I missing? How many W's do I have here? 2. And how many W plus 4s do I have? 2. Now, unfortunately, this is one perimeter formula. Some of you guys know 2 width plus 2 length. You don't have to memorize any perimeter formula because it's just add up all the sides. Now, real quick, the way I would do this is if I do W plus 4, does anyone know what it's supposed to equal? 46. Why does it equal 46? Because I only went how far? Halfway. So half of 92 is 46. And sure enough, if I divide by 2, I get that. Who cares? Whoop-de-doo. Who cares about that? That's bullshit. So now I just get 4W plus 8. Is that cool? Is that all right? All right, now it's easy. I almost don't want to do it. It's just easy. Yeah, okay. The hardest part about any word problem is actually setting up the function you're going to use. Let the calculus be easy. So let's look at more of a, like a problem that we're going to see. Okay. You got to keep track of all the stuff I've given you. So on the back of this one is something that's going to come up much later. So don't put that away too far. We're going to use that. Here, yes. Where did the trough problem go? There it is. What was in the back of you? Okay, this, good, good. So on the back of the trough problem, and again, I'm really sorry this is all a little out of order, but oh well. This is what I want to do next. This is kind of like the bridge to where we're getting to. Can you guys try to do number 1? Actually, let me help you out. This is a little weird. You can draw a picture, correct? How does the 40 relate? So I've drawn a picture. What dimension, what things do I need to give variable names to? Length and width, so we call that WL. So length is W. Jeff, length is L. Width is W. Do you see how there's something I tell you and there's something I ask you? So I call these tell me, ask me problems. They tell me something and then they ask me something. What geometrical idea do I tell you the information about? Perimeter. I just tell you the freaking perimeter is 40. Right? You're like, please give me more. Just tell me what the number is, dear God, Jeff. So the perimeter I tell you is 40. What's the equation I can write for that? The perimeter is 40. 2W plus 2L equals 40. So I write an equation for what they tell me. What are they asking me? Area. And what's the area from just the picture? Yeah, length times width, yeah? Okay. I want the area as a function of width. At the moment, what is the area a function of? Length and width. I want it as just a function of width. So what letter do I want to kill? Or replace in the middle of the night? L. I want to get rid of L, correct? When you're at this stage, they ask you something, just like before, just like with the trough problem, I want to get rid of one of the variables, because they don't want to do a product rule, I don't have information about freaking W in that case. Can I use what they told me to help with what I'm trying to do now? What can I do with the equation that relates to what they told me that will help me do what I'm about to do? What letter do I want to get rid of? L. So what do I want to do with the equation from what they told me? Solve for freaking L, because then I know what the hell L is. So I call these tell me, ask me problems, because they will almost always tell you something, volume, whatever, and then they'll ask you something. So if you just write an equation for both of those, you can see how they want to interact. Are you with me? That what they told me is obviously the perimeter, correct? And we know the formula for the perimeter of a rectangle. Easy. I can write the formula for what they told me. What they asked me is equally easy. It's the area of a freaking rectangle. Length times width. That's easy as shit. Now I say, how do those work together? How do I solve the first one for L? Yeah, I can divide by 2. I like it. So I get W plus L equals 20, yeah? So then L is 20 minus W. So I get the area is 20 minus W times W. So we call that? I just replaced L with what I know it to be.
Where did the times W come from?
So again,
Where did the times W come from?
because what's the area formula? L times W. And what's L?
Oh, that is it.
20 minus L. All I did was replace L, and the W is just sitting there. Does anyone know what that would look like if I graphed it?
The quadratic with an intercept on the negative one.
Quadratic is a statement about the equation. What would it look like? Parabola. Opening down. Okay. Down there. It's a little arrow on the way. Okay. So one thing I could do is to just distribute the W. Is that cool? You guys see better now that it's a parabola opening down? Okay. Do I have to know all that for number 1? No. Okay. So did we get the area as a function of width? Totally. That's all it wanted. Now, of course, in your homework, you would keep going from there. If you were in pre-calculus, you would use negative b over 2a. Here, you just take a derivative, get it equal to 0. What would I be trying to find if I got the derivative set equal to 0?
The tangent line of the parabola.
Where the tangent line is 0, and that would be the what? That would be the greatest possible area I can make. In this case, it'd be greatest area. If you have cost, you normally want the lowest cost, of course, right? So it depends on what shape that takes. Okay. Read number 2. So if you have any trouble drawing like a cube or a rectangular solid, you with me? One way to do it, I'm sure somebody in here has seen this. You draw a rectangle, you draw the same rectangle, and then you connect the corners. Yes? So I got a rectangular container with a square base of length x. So what can I put on my picture? Yeah, the base, this is x, and this is x. So the base is a square. Is that cool? And the height is h. Okay, so far, we've just directly put down what they've told me. Yeah? It's to be made from 1,000 square feet of material. Yes? So they tell me 1,000 square feet of material. And they ask me, what do they ask me about? Volume. Now, real quick, can somebody, all right, let me stop for a minute. This is a beautiful example of not everybody has the innate ability to break a problem down into parts. And the people that are able to do that naturally have an easier time with math. Ooh, good for them, right? Sort of like if anybody's able to draw really. Is anybody able to draw really well? Anybody able to draw really well? Were you able to kind of do it from an early age? So you can kind of see the shapes that go into different things, right? You can see there's an oval. I can't do that shirt where, I don't know if you guys can tell. I have trouble with drawing it, right? It's incredible. I cannot do that. I could work really hard and get to a point where I could do that, but I don't naturally do that. You guys are all with me. So I suck at drawing. I'm completely cool with that. You have to realize, if you do this tell me, ask me, you are breaking it down into parts that you can focus on one at a time, instead of believing you're supposed to have the whole problem in your head. That's insane. Can somebody tell me the formula for the volume? Yes, length times width times height. That's easy, right? What is that? X squared h. And what's wrong with that equation? The number of variables is too damn high, right? Okay. What does this relate to? Surface area. You with me? 1,000 square feet of material to construct the box. The inside hopefully is empty, or else, doesn't really contain much. So what is the formula for the surface area? What's the area of the bottom?
X squared.
X squared. How many of those are there? So I got 2x squared plus, what's the formula for one side? Formula for one side? XH, and how many of those do I have? So here's what they told me, and here's what they asked me. Let me stop for a minute. What variable do I want to get rid of in the volume formula? Because they tell me to write it as a function of x, right? What do I do? Yeah, I take what they told me and I solve for h. The letter you want to get rid of, you solve for it, because then you're able to replace it. So how do I solve this for h? Subtract 2x squared, and then divide by 4x. Is that cool? Can you guys see that? Subtract 2x squared and then divide by 4x. Is that all right? And then I just take this and I plug it in for h. And see how stuff cancels and you reduce your numbers? That part I don't care about too much. But now if they ask me to find the maximum volume, what calculus would we do? Take the derivative. Now, dear God, I'm going to freaking simplify this shit. I don't want to do product and quote, are you kidding me? I'm going to simplify that. Are you guys with me? But the basic idea is I would take a derivative, set equal to 0, find the tangent lines, get the maxes and mins, blah, blah, blah. Okay. Let me stop for a minute. Yes? No, there's 4 sides though. 1, 2, 3, 4 sides of the box, yeah? 1, 2, like we're in a box.
Yeah.
We're all in a box. And there's 4 sides around us. What's in the box? Bunch of students. Okay. In a head. That's right. Is that all right? We're basically done. I mean, you can simplify, but we got volume as a function of x, yes? You can kill an x, blah. Number 3, do number 3. This is the one that relates to that problem on the test. Very, very, very directly. Number 3 is much easier than anything we've done. Number 1 or 2. What's the one little tricky thing? Yeah, the volume currently is a function of what? Radius and? Height. So the volume is currently a function of radius and height. And I tell you the height is 3 times the diameter.
D is basically 9 order.
Say again?
3D is basically like 9 order.
3D.
You get 3 diameter. Basically like 9 radiuses.
No. So what did they tell me directly? The height is 3 times the diameter. Is everybody with me on the trouble here? Does this involve the variable that I needed to involve? No. But of course, diameter is how related to radius? 2 times the radius. So isn't this 3 times 2r, which is 6r? Okay. You said 9, so that was a problem. You didn't? Yeah. You might have been thinking 6 upside down. I don't know. So they tell me this. Now I've got it in a version that's relating the variables I've got. Yes, so you guys see that? H and R, so this involves H and R. And they ask me about the volume, but they want the volume only as a function of height. So what's wrong with the way this is written right now? Does anybody see what's wrong? If I plug this in, what letter am I gonna get rid of? H. Do I want to get rid of H? No. So what do I do with this equation? Divide by 6. So now I know the radius is 1/6 the height. So again, do you know which letter you want to get rid of? So you know which letter to solve what they told you for. What can I do with this now? Plug it in. So this is very much like the problem on the test. So there I told you the radius was 1/4 the height, or the other way around, I can't remember. So this would be pi h squared times h, 6 squared. Is that right? And now that I could do derivatives of and do all kinds of stuff. So all I did was plug in h over 6. I plugged it in for r. I squared. I got h squared times h is h cubed. 6 squared is 36. All right, we're going to do number 4, then we'll take a break, and then we'll actually do some calculus. What do they tell me in number 4?
Volume.
Yeah, the volume. And what's the volume of a cylinder? I gave it to you. What? Yeah, it's right there. Volume of a cylinder, pi r squared h. And I tell you the volume is 60, yes? So that's beautiful. Almost every problem, there's going to be something they just tell you. And you're like, thank the gods. And you write the equation related to what they told you. What are they asking me for?
Surface area is a function to radius.
Yeah, so currently the surface area is a function of what? Radius and height. And they want it as a function of just radius. Do you guys start to see how this is kind of repetitive a little bit? So what letter do I want to kill? H. So what letter do I want to solve this for? H. H. Because then I can replace H. I want to get rid of H.
How did you know the formula for the surface area?
It's right there.
Oh.
But also it's just cylinder. What's the shape on the top and the bottom? And how many of them are there then? 2, yeah? 2 circles. Now, real quick. I'm kind of happy you asked. So, can I make a cylinder? Is that a cylinder? Is that a freaking cylinder? Yeah, okay. Ignoring the 2 circles, I'm going to take them out. I'm just going to focus on the 2 pi r h part, right? You guys with me? What's this length all the way around? That's the one of the circle. Isn't that 2 pi r?
Yeah.
Okay. If I open this up, isn't this 2 pi r still? And what's this? Let me make sure this is nobody's. Oh, this is somebody's. What's this? H. So what's the area of this? 2 pi r times h. Right? So top and bottom circles are 2 pi r squared. And then if I open it up, it's so cool. If you chop off a Campbell soup can label to send it in, I don't know if any of you guys ever did that. Back in the day, we were listening to 8-track tapes and we were cutting off soup can labels because it was so exciting. If you cut it off and you open it up, it makes a freaking rectangle. So of course it's easy as shit to get its area. So this is the idea of taking a weird shape and making it something we know, and then its area is easy. Do you have to know all that? No, because I just gave you the formula. So, but I just want to show you where it came from. Where did I get this from? Who knows? All right. So what do I want to do with this? Solve for h. And then I just take, pi r squared. So I just take this, plug it in there, and I've got what it wants. Yeah? Every single problem we just did was like the first step of a calculus 4.7 problem. then it would want you to find the maximum or the minimum, whatever. That's why we call it optimization. We're trying to optimize the situation. Find the highest profit, find the lowest cost, find the maximum area, find the lowest amount of materials needed, all that kind of stuff, right? Maybe so just to make this, so it'd be 2 pi r squared plus 2 pi r 60 over pi r. And what do the r's do? I'm sorry, is it squared? Yes, it is. One of the r's cancel, yeah, blah, blah, blah. And the pi's. Cancel, okay. So let's take a break, and when we come back, we'll do this kind of stuff, but we'll do the calculus to it. So come back, Portis Hill. If you have any questions, come up and see me. Tell me if this sounds familiar. Let's see. Well, maybe not. I've got property, and I've got a river in the back of my property, right?
Texas.
That's my dream right there.
Okay. Continue.
That's my dream, the river, behind my property, that's my dream right there.
Oh yeah, exactly. All right. So we're all dreaming about a river. Oh, well, here I am living in the van down by the river. So be careful, kids. I have captured an orc, and orcs famously don't like water. So I want to contain this orc. So I'm going to make this pen, and one side of it's right at the water. Are you guys with me? So I only need 3 sides. Is everybody with me? Okay. So I have 80 feet of fencing, and I want to know what's the largest area I can give my little orc room to play in. Right, here's my little orc. Okay. So I'm going to give him a lot of room to play in so he's not so angry. Right? So everybody with me? So obviously what I'm going to make, well, let me just, that's not obvious, but I'm going to make this rectangular because I just really like rectangles. So I want to know, so again, let me summarize. That's what I tell you, and the question is, what's the maximum area for this little orc to roam in? Yes? Okay. So can you break it down? What are the 2 parts you try to break it down into to help you focus? Focus. Tell me, ask me. So what is it that I just tell you? Yeah, so in order to capture this is what I tell you. I just straight up tell you, we got 80 feet of fencing, I want to use all of it. What's the formula? And before I can make a formula, what have I not identified yet? The parts, right? Who are the players? So what do I have to give variable names to? So what do you want to call this width here? X, cool. And what do you want to call the length?
X squared.
Yeah. Do I have any idea at the moment how these are related? If I call this x squared, I'm saying that somehow I know this has got to be the square of that side, and that's more than we really know. We have no freaking idea. Okay. Let me stop for a minute. Drawing a picture is a really good idea. Identifying what needs variables is the next step. Now you can write an equation for what they tell me. So how do I write the equation for what they tell me?
2x plus y equals 80.
Yes, so notice, of course, since I have one side going up against the river, I don't need 2 y's. So the perimeter here is 2x plus y equals 80. That's crazy. Let me stop for a minute. You guys? Okay. What do they ask me? Area. What's the area from the picture? X times y. Yeah. Now, I'm trying to make you understand. Not every problem is going to necessarily flow into this, but most of them will. Most of them will flow like this, and most of them you'll have too many variables, and then you try to get rid of one of them, right? Now, I did not tell you in this problem what I wanted a function of. I don't give a shit. It's up to you. What variable is easier to solve for here? Y, yeah. Alright, so try to rewrite the area in terms of one variable. Go. Oh, wait. Rewrite the area in terms of one variable. I just always want somebody to go, area equals A. There you go, Jeff. No, stop. All right. When you solve this, what do you get?
80 minus 2x.
It's not time, so division ain't gonna help us out. 80 minus 2x. And of course, now I know what y is. Now, listen, I don't blame you for like, we don't know what the freak y is, Jeff. What the shit's your problem? Yeah, I do. It's 80 minus 2x. That's algebra. Algebra is pretending like, oh, y is 80 minus 2x. We know exactly what this shit is. Anywhere I see y in this problem, I can replace it with this shit, because that's what y is. So what's area now?
80x.
Yeah, x times 80 minus 2x, so it'll be 80x minus 2x squared, kick ass. So now we're finally going to do some calculus today, right? Jeff Goldblum. Is there going to be any calculus in this calculus lesson? So now I'm trying to find the maximum area, so what do? Derivative. Yeah, so what's the derivative?
80 minus 4x.
Can you solve for x? Well, what in order for it to be some kind of a max or a min, I've got to find the critical numbers, right? How do I find the critical number? Yeah, it's either undefined or 0, and it can't be undefined, so I've got to see where it's equal to 0. And that's nice. What do you get? 20, yeah. Now, for this specific problem, we know this is a maximum. Why do I not have to do any checking to make sure this is a maximum? Because what shape is this?
Oh, yeah.
Parabola.
Down.
Down parabola. So I know that the critical number is going to be, well, it's going to be maximum, right? Now, if I want to check it, I could do the second derivative. What's the second derivative here?
4.
Negative 4.
-4. What's that mean? The second derivative is -4. What does that mean? This is always concave down. Therefore, any critical number is going to be a maximum. So I can do the second derivative test, right? Somehow, what's up?
What does that mean?
What does this mean? That's my question. Second derivative tells you about the concavity. If it's concave down and there's a critical number in that region, that number must be a freaking maximum. That's the second derivative test. The second derivative test kicks so much ass. Until it doesn't. If you got 0, that sucks. That means you can't determine it. You have to do the first derivative sign diagram. Are you guys with me? See if it's going down, then going up, or whatever. Okay. So again, I need you to understand. It took us a while to develop the function we were working with, yes? But then the question is, find the maximum. All right, that's find the critical numbers. We've done that before, right? Local max, local min. So what do I do from here? Does this tell me how big my orc pin should be? Yeah, what are the dimensions? Let's do that first.
What do you mean to find y?
Yeah, if x is 20, what's y? X is 20.
40.
80 minus twice 20 is 80 minus 40 is 40. Do we know what y is? Yep. If I know what x is, then I also know the number, which is nice. I know x is 20, therefore y is 40. Is that all right? The minute I figure out what x is, can I figure out what y is? Of course I can, because I know y is 80 minus twice x. whatever the hell x is, I double it and I subtract it from 80. So y is 40, so this would be 20 by 40. 20 by 40 what? Yeah. So what's the area?
So 800 times 40.
800. So- 800 square feet. Alright. So that's the biggest area I can make. This, what shape does that make? Rectangle, right? It will always be a square if I'm making all four sides. I need you to see how this is still a square in a way. What's the total fencing I used in this direction? Yeah, x is 20, so this is 40. What's the total fencing I used in this direction? 40. So it's still 40 by 40 in a way. It's still a square, sort of. I'll show you that same thing in a minute. So if I said, I want to make a rectangle, and I have this much perimeter I want, it's always a square. That will maximize the area, always. You guys are all with me. What, have you guys ever seen silos? I'm a Georgia boy, so what do we have in Georgia? We got tea, and we got peanuts, and we got cobbler, we got all kind of weird shit. We got black eyed peas. You go out and you see these silos. What shape are silos? They're holding grain and stuff. It's a cylinder, right? The funny thing about that is, if I want to have a certain volume, the shape I want to use is not a square base, it's a circular base. That makes me have to use less material to make it. Are you guys all with me? Especially if what I'm filling it with is like stuff that can really fill it all in. If I'm putting boxes in, I don't want a cylinder because then you're not using all the space. Are you guys with me? But if I'm filling it with grain or some stupid little thing, peanuts, then it's gonna fill that shit. I'm gonna use a circle because then I have to spend less money on the freaking material to make this shit. Did we use math to figure that out first? No, we actually just kind of experimented. And then math came in and said, oh yeah, you guys are doing it right. Good job, humans. All right, I'm sorry. That's all on the side. So in this case, if I want a four-sided figure, parallel sides, to maximize the area, it's always a square unless I'm missing a side or something, right? But even then, it's still sort of a square. I used 40 this way, I used 40 that way. So let me give you this handout now as I tie my shoe so I don't die. Okay. So I have two problems on this handout. The first one has 4 parts and the other one has 2 parts. So back. You guys try to do the first 2 steps there. See how far you can make it. Feel free to work with people near you if you want to. If you don't trust those people, then hide your paper from them. Ooh, that was mean. Wow. Okay. One little thing on part B you gotta be careful about. So what are you guys using for the, what do you call the width here? You can call it W, I like it. Doesn't matter what you call it. So this one I'm gonna call L. If you used X and Y, great, nothing wrong with that. So what's the formula for the area?
Length times width equals 1/8.
And I tell you that it's 1/8. Cool. So there's the area as a function of length and width. Let me stop for a moment. So it's all about, I'm gonna give you a number related to something. You write the formula for it, so it's just in my back pocket. I could use this information anytime I need to. Now, what's interesting about part B, and by the way, let me label this all the way around. Okay. Can you guys imagine a situation where I would need, and by the way, real quick, you see where I'm being evil? I was just pointing at it.
Converting.
My units of measurement are feet, right? Except for one place. How many feet in the yard?
3.
So this is $45 per 3 feet, so how much per foot? 15. So just gotta convert that. Just to highlight that you need to be careful in the homework. I can't remember if they do this, I think they do this somewhere. They put centimeters and meters, oh shit, you gotta remember how to convert that. Can you imagine a situation where one side of fencing needs to be like an upgraded kind of type of fence, possibly?
Board.
Something, yeah. You could have a situation where one side of the fence, you have to use kind of like better fencing and the other side doesn't have to be. So that's the situation we're in now. For some reason, one side needs stronger fencing. That's why it's more expensive, right? Or maybe it's a certain color, whatever the shit the situation is. So you might ask yourself, how did I get to this? No, you might ask yourself, which side? It doesn't matter. Somebody pick a side. So let's say 1, 2, 3, 4. Which side? 1, 2, 3, 4. 4, okay. So we're gonna put the kick-ass, crazy expensive fencing here. You guys with me? All right, so let me redraw my picture. So here we're gonna put the $15 per foot. And over here we're gonna put 10, 10, 10. And I'm gonna put here what they all are. So can anyone tell me the cost? What's the total cost of fencing this area in?
Depends on how long it is.
Again, algebra. If you say the speed was 80 minus W, there it is. Speed is 80 minus W. There it is. It's right there. So again, what's the cost?
15L.
15L plus 10W plus 10L plus 10W. Whatever the hell L is, wouldn't I multiply by 15 for that one side? That would be the cost for that side. So algebra says, too bad, human. I know you don't like letters, but that's what the hell it is. Whatever L is, the cost would be 15L. Now I do that for all the sides, get the total cost. What do you think we're going to want to do here? What do you think my end goal is going to be? When it's cost, what am I going to want to do with that? I'm going to make the cost the highest, yeah? No, of course, I want to make the cost the lowest. I want to figure out the minimum cost to make this work, yeah? Okay. So the cost function is what again? It's going to be 15L plus 10L plus 10W, 10W. What's wrong with that formula that we've been talking about? What's wrong with that in terms of, I want to take a derivative, all that kind of stuff? Too many variables, right? The number of variables too damn high. So, what do I do?
So isolate one.
Yeah, so part C, I'm more specific. It really doesn't matter, but part C, I tell you, solve the area equation for length. So let's do that. Go ahead and solve the area equation for length. It really doesn't matter which one you solve for. For some reason, I just chose to do that.
It doesn't matter.
Because you're going to have to know the dimensions at the end anyway. It doesn't matter if I figure out L first or if I figure out W first. Whatever one I figure out first, I'm going to figure out the other one. It doesn't matter which one I figure out first. Does that make sense? Okay. So it doesn't matter which letter I solve for first. So if I solve this for L, what do I get?
180 W.
Yeah, L equals 180. Over W, yeah. Of course you gotta divide, because it's multiplying. Okay. So take a moment, rewrite the cost function using that information. Yes?
How did you get that? L equals.
I'm just solving for length. So how do I get L by itself? What do I want to get rid of? W. And the operation's multiplication, so of course I divide to kill it. Yeah?
No, I just wrote A for that. I didn't write it out.
Oh. Yeah, we know that the area is 180. So what's your cost function look like now?
25 plus 180 W plus 20.
So how many independent variables are there? One. Just W. Let's clean this up a little bit. 25 times 180 is 50 times 90 is 4,500? Yes. Is that right? Okay. This, if I know the width, I can figure out the cost. That's what this formula can do for me. So when I'm constructing, so can you guys envision in your head, there's no fence yet, but I'm going to start to put the fencing out. What can I adjust as I create this shape? Does it have to be a certain shape? What can I adjust? So could it look like,
Well, it said it had to be a rectangle.
totally, but could it look like this?
Oh, yeah.
Of course it could. Could it look like this? Yeah, so what can change when I set it up? The width and the length, correct? The area can't change. I want the area to be 180, but I can certainly change the width and the length. You with me? If the width was 10, the length would be 18, or you guys, does that make sense? Because now that's 180 for the area, correct? Let me stop for a minute. I want this to make sense what's next. This section, believe it or not, is better than related rates. The weird thing about related rates was we took derivatives with respect to t, and there wasn't any damn t anywhere, right? Nobody had no t. So here, I'm going to take the derivative. What is changing as I alter the shape of this rectangle is the width. So I'm going to take the derivative with respect to the width. So now, find the critical numbers, I take a derivative. Okay, so let's rewrite this first. What's a better way to write this piece?
4,500 W is the negative.
So now if I take the derivative with respect to W, how do I do this piece? Right? Same old shit. Right? That's beautiful. Yay. Plus 20. Now where are the two places I get critical numbers from? Where the function is, where the derivative is 0 or where it's undefined? Can anyone tell me where this is undefined? At 0, this is undefined, correct? That is an extreme. Can anyone tell me what that extreme would be? What does it mean for that variable to be 0? What does that mean physically?
No width.
There's no width. So I just put all my fencing in a row. How big is my area then? Freaking 0, because this width is 0. So that is one extreme. That is the way to make the least area. Or to make the cost, and that would not even be an area. So that wouldn't even make any sense. So the critical number that comes from this being undefined doesn't make physical sense. So I can ignore it. What's the other place to get a critical number from? Either the derivative is undefined, or I set the derivative to 0. Go ahead. Oh, wait. Solve that. Yeah, okay. She get a nice answer, I believe. Yes. Maybe. We'll see. Yes. just to give you a little hints about stuff. If you're setting this equal to 0, it's a little better to write this like this. But you don't have to. If you can see how to do it without doing that, that's great. But alright, so let's see. One thing I would do, alright, what would I do? I don't like the fraction, yeah? You guys like that fraction? First thing I would do is multiply by w squared. You don't have to. Then you bring the 4,500 over, divide by 20. Is that alright? What's, bam bam, 450 divided by 2 is, and then when you take a square root, 15! Look at Jeff giving you a nice answer. 15 what? Fuh. Now what is it the question wants though? The cost. The minimum cost. We just figured out what? The width that makes the cost an extreme value. Have we shown yet that this causes it to be a minimum? You could do the second derivative test. Let me make sure everybody's with me. Does everyone agree this is a critical number? What could occur at a critical number? Max or min. It is where the slope is 0, but what could occur is a maximum or a minimum. Now what could also occur? A little fake out, right? So I need a minimum cost, correct? So I gotta make sure this actually makes it a minimum, not a maximum. That would suck. If I'm in a job and I tell my boss you're 50 feet and then it's a maximum cost, I'm probably not gonna have that job anymore. It's like you had one job, Jeff. What the shit? Yes.
Why did the W squared change from the 4,500 to the 20?
What? What's that? Sorry. Oh, if I multiply by, whenever I have a fraction in an equation, I can multiply by its denominator to kill it, yeah? Anytime you have an equation that's got fractions in it, multiply by the LCD, you don't have any fractions anymore. Did you have to do that? Nope. Did anybody cross multiply? What did you guys do? Maybe I should have answered.
I'd rather do that since you're making sure.
Yeah. that's what I was trying to
Oh yeah, you subtracted 20?
say. But then I had to,
But then it'd be like negative, or negative 20.
Yeah, so
or
if you
negative
start over
4,500.
again, if you have, where'd it go?
Like
Negative 4,500 plus 20, I'm sorry, over W squared equals 0, yeah? So you subtracted 20?
Well, I wrote it out like the
Oh.
negative second. Too.
Okay, sure, let's see. Negative 4,500, W to the negative 2, like that?
Yeah. That's fine. Yeah.
Okay, what'd you do?
Minus the 20,
Minus 20? I love it.
and then 4,500. Or negative 20 divided by.
Negative 4,500.
Good?
And then I just stopped because I looked up at the screen and that's now.
Oh, who cares? There's multiple ways to do this.
Yeah.
Like I said, I just picked a way that I thought of. So what here, see a 0 cancels? The negatives cancel, and you get 1 over 225. I'm just reducing, don't look at me like that. I can kill both by 10, I can kill the negatives. And then 2 over 450 is 1 over 225, just reducing, that's it.
Mm-hmm.
How do I keep going?
Square root.
What sucks about this thing, I can't square root it because this is a negative second power.
Negative root.
So can't I just flip both sides? What's a negative mean? Flip. So if I flip both sides, that becomes a positive now. Yes? And then you just square root and get the same place we got. Okay. I highly recommend, if you're trying to solve an equation with a negative exponent, write it on the bottom and then multiply by it to clear your fractions. It makes things a lot more streamlined.
That goes the same, like the opposite way, right? So it's the w to the -2, and it's, 5, right? Then it would end up being 1/5.
So W
Oh,
negative
oh,
2 equals
Oh, if you had
5.
w to the -2 equals 5,
Yeah.
Yeah,
that would be w squared equals 1/5, yeah.
okay.
Okay, because you just flip both sides.
Yeah.
Okay. Alright, so I've got one suggestion as to how to make sure this is a minimum, is to do a second derivative. Second derivative wouldn't be that bad, yeah? Alright, what would the second derivative of this be?
Of which one?
Of the cost?
The 2 times 4,500.
-2 times -4,500, 9,000. It's over 9,000. Okay. That's the second derivative, and now I want to know at 15, is that cup up or cup down? And you guys see how this is always positive? Can the width be negative? If it can be, I want you to bring me a rectangle with a negative width. Maybe I don't. I'm not sure what that would do to everybody. Little black hole thing. Look, I did it. Give me a get sucked. Let me make sure you guys are really cool with this. Second derivative tells you about the concavity. If it's concave down, critical number is a max. If it's concave up, critical number is a min. It's that simple. This concavity is always positive. So therefore it is concave up. Any critical number in there would have to be a minimum. There, we showed it. That causes a minimum cost. Secondary test is so awesome, so I don't have to draw the freaking sign diagram. Yeah? I can just do a second derivative and see if it's positive or negative. Let me say this again. If I have a cup up situation and there's a critical number in there, it must be a minimum because it's freaking cup up, so of course it's got a bottom. If it was concave down, it would be maximum. It's almost too nice to believe. Second derivative test. So what's the cost? At what cost? Do we have a cost formula?
Yeah.
Yes. Do I know W? Yes, so just plug that shit in. So let's see, 15, what was it? 15, oh fudge. 12,
What was it? That's two
4,
W's.
300 plus 300, 600. Is that right? Dude, alright. So the cost would be $600. That is the minimum cost to meet the requirements set out. Yes.
How did you know which equation to plug that into the W?
What is it that I want?
The minimum cost.
Which function represents cost?
We have a-
Does this function represent cost?
No.
Nope, this is the rate of change of cost. So this is the cost function, so then I'll just plug 15 in there. That is the cost function, yes?
There's a Korean.
So if I, oh, they're all the same, yes? Sorry, they're all the same. It doesn't, I could have put it in here,
Okay,
but this was just easier to do in my head.
got you.
Yeah.
Can you explain how you prove it's supposed to be a minimum or not? Okay.
So, are you cool with this being the second derivative?
Yes.
Okay. Do you agree that width has to be more than 0?
Right.
Okay. Therefore, this is always positive.
Yeah.
So if it's positive, that's cup up. So any critical number must be a minimum then. So if I know there's a region over which it's cup up, any critical number automatically must represent a minimum. If I had a region where it was cup down, any critical number must automatically be a maximum. That's the power of the second derivative test, yes.
What does the -3 tell you? The power.
Doesn't tell me shit. It's just sitting there. This here? Yeah, all that matters is the sign of this thing. What's the only way this could be negative? If I had a negative width, is that physically possible? No. Therefore, this is always positive. In fact, to be really specific, our width is 15. You could put a 15 in here, but you don't have to. You're going to get a funky ass answer, yes? 9,000 times 15 to the negative third power is going to be funky. All I care about is it positive or is it negative? That's it. If it's positive, minimum. Negative, maximum. Maybe. Yes. Oh, you're good. So our cost is $600. Can somebody, let me see if you guys can do this. Do you remember, real quick, do you remember I drew somewhere an option for this? I just need there to be 180 square feet of area, correct? Can somebody give me another rectangle that makes that happen? Tell me what the dimensions are. I gave one earlier. Say again? 30 and 6, 11. Wouldn't this make 180?
Yeah.
Yeah, okay, so if I calculate the cost for this, 6 times 15 plus 30 times 10 plus 30 times 10. Do you see how even just, let me see if you guys are really with me. Are you guys, so let's say this is the special fence, 6 times 15. Now real quick, I'll show you why that doesn't matter. Wouldn't this be 30 times 10?
Yeah.
Wouldn't this be 30 times 10? Isn't that already $600?
Yeah.
Isn't the whole thing gonna be more than this? That's a verification that it makes sense. This is the minimum because this is only one situation, but I figured I made a random situation and it does have a higher cost. That kind of doesn't prove it, but it verifies this seems to be a lower cost relative to other ways to construct this. Okay.
So, to verify if you have the minimum cost, or like if your equation, or if the numbers you chose, work for the minimum cost, you have to take the second derivative of it to see?
To make sure that this critical number
Yeah,
is a minimum.
okay.
If our second derivative was negative at 15, it would have been a maximum cost.
Mhm.
If I report that, I'm getting fired,
Okay.
right? You cost the company money. Right? And I'm like, I don't care, I want to work here, I don't want to. Alright, let's look at the other side. So there will be problems in the homework that are like this.
So this is like all one question.
Yeah! That was nice and broke it out into parts. Read through that. You definitely have some like this in the homework also. Alright, this will immediately freak you out. So let's remind ourselves. One thing you have to remember is, how do you find the distance between 2 points? Recall. If I have 2 points,
Y2.
x1, y1, and x2, y2. No? Say this is x1, y1. So I'll say this is point A and this is point B, okay? I want the distance between them. If I knew how much the x has changed and how much the y has changed, what picture have I just made? What shape? Holy shit. And of course, what relates the sides? Old Greek dude, right? That's right. This side, isn't this y2 minus y1? Isn't this side x2 minus x1? And we'll call this side distance. So therefore, distance squared equals?
Y2 minus.
Yeah, I'll do, you're right. I'll just do it this way just because I like to put it in alphabetical order, but you're fine. Do you remember this distance equals square root of all this shit? That's the distance formula between 2 points. It is Pythagorean theorem because our xy coordinate system, you can make triangles easy as shit. They go over and up. I made a triangle. Ooh. So I specifically want, now here's the thing. Did I give you 2 points?
No. Gives function.
I did. What point, those of you saying I did not give you 2 points, what point did I definitely give you? 2, -1. There is another point I have given you. What's true about the other point?
Other side of the parabola.
Where's it gotta be? It's gotta be
Other side of the parabola.
on this parabola. So let me see, if you want to. X squared minus 1, you guys with me that it's x squared, move down 1? So that's really easy to graph. I'm not gonna make it perfect, I'm just gonna do it real quick. 2 negative 1 is over here. So I wanna know, if I have something coming around the corner here, when is it closest to this point? Do you see that? So it won't be over here, that's longer. There's a sweet spot right there. Does everybody agree with me? There's a sweet spot. So we're trying to figure out what is that closest approach.
And that's-
We do that with, if we see asteroid coming. We calculate its trajectory and go, dear God, let the closest approach not be 0. Closest approach 0 means we're all dead. Or we say, Bruce Willis, how you feeling, man? Can you go up there with, what's his name? Blow the thing up. Anyway.
And you call that distance the squared distance?
I'm going to talk about, hold on. So the other point is on this parabola. You guys with me? Because I want to know the square distance between any point on this graph. So let me say, here's any point on the graph. You agree with me? Of course you do. Okay. Now let's be more specific. What the shit is y? In order to be on this graph, what must be true about y? You can do it. It must be x squared minus 1. There. So this is the specific point that I'm trying to get close to, and this is every point on the parabola. If I tell you x is 1, what's the point on the parabola?
0.
1, 0. 1, 1 minus 1, 0. I mean, if I tell you x, wouldn't you just plug it in there to figure out y? So of course it's x, y. X function. That's the point. That's every point on the graph, yeah?
Question though, when you
Yeah.
plug in 2, the y output wouldn't be -1, would it? Is
Of
that-
course not. Because, real quick, if that point I gave you was on the parabola, it would be the answer. I need you to understand. If I had said, so what did we just get? 1, 0, yes? So if I put 1, 0 here and I said, when do you get the closest to 1, 0? The answer is 1 frickin' 0, because it's on the parabola. So where can I go on the parabola to get closest to the point 1, 0? 1, 0. It's done. The problem is done. So of course I'm going to have a point that's not on the parabola. I want to know how do you get closest to that point? Where would I be on the parabola to be closest to that point? Let me stop for a minute. So this is an application of cosmology, right? Astronomy. We're talking about closest approach of things. So this is a really important problem to be able to do, obviously. So we make sure, are we about to go extinct, or is there something cool we can go out and look at? This process here, does it care what points I give it?
No.
I give it any frickin' point and I can do this process. You guys all agree with me? Agree with me? All right, here's 2 points. Yes? Do the process. I'll call this one x1, y1, and I'll call this one x2, y2. And let me see, just to make sure you understand why I keep this as d squared. If I took a square root, can you imagine taking the derivative of this? Wouldn't it be this big ass chain rule if I took a square root? So I just don't take a square root. If I make the square of the distance the smallest, isn't it the same thing as making the distance the smallest? So then I don't have to take a square root and make a big ass chain rule for myself?
And then we solve for it.
No. So I want x2 minus x1. What did I say x2 was? X. And what's x1?
Negative 2.
It's 2. Yeah. What's y2?
X squared minus 1.
And what's y1?
X 1. So plus
11. So the square distance equals, you can multiply this out, is that cool? What happens in here? These cancel, yes? And what's x squared squared? Alright, let me stop for a minute. So I'm just simplifying the function that I've set up. So let me make sure you guys are with me. Distance formula officially is the square root of the distance between the x's squared plus the distance between the y squared. If I'm going to take that derivative, that sucks. It's a big ass square root with a bunch of shit inside. That's chain rule. Do you all agree that if I minimize the square of a distance, that minimizes the distance? If I make the squared number the smallest it could be, I just made the number the smallest it could be, if it's positive. So help me out. Do we have a function that represents what I'm trying to optimize? Does this function represent the distance between the 2 points to some degree? It's a square.
Yeah.
Okay. Any function I set up, how do I make it? And in this case, am I trying to make it the maximum or the minimum? Closest.
Minimum.
Minimum. So what do I do? If I have a function, I'm trying to find its minimum, what do I do? Take a derivative, set equal to 0, or see where it's undefined, right? Find the critical numbers, right? Go for it. Now, and just to make sure you understand, d squared is the function, so watch this. When I take the derivative this side, it's just the derivative. Don't worry about that, right? That's the function, so I don't have to, like, do it. This is easy as shit, yes? So what do I get? 2x.
Minus plus 4x.
I like it.
Question, where did the negative 4x come from?
So it's factored.
Foiling this. Yeah, foiling this thing. Right, x minus 2 twice.
Okay, I got you.
And what do I want to do with this? Set it to 0. Now here's where we're going to have some fun. So we're going to divide by 2. Can I factor that easily? No. You guys agree? If only it was a squared, we could factor that easily, right? Does anyone know what I can do then? Say again?
Plus x, what, minus x?
No. Oh, I see what you're doing. No. That's good. I like that idea. Huh? Does this have an x? No. So if this thing factors, do you all agree with me that there's got to be a 2 somewhere here? Because there's a 2 there, right? Either it's a -2 and a 1, or a 2 and a -1. You guys agree? Okay. We've done this once before. I should probably bring that paper, but I can synthetically divide this. Okay. So I know there's got to be a 1 or a 2. I don't know if you guys remember, you make the factors of the last dude divided by the factors of the first dude. So it could be 1, 2, or 1/2. Does this sound familiar to anybody? It's a good example of pre-calculus, helping with calculus. So synthetic division. Let's just pick 1. Let's try 1 out. What are the coefficients of these in decreasing order of power? 4?
4, 2, negative.
Nope. 4, 0, because there's no what's?
Squares.
X squares.
2.
2. I'm sorry, I should have been here. I love you guys so much. This will work fine. We could use this one instead. There we go. Kind of sucks a little bit, but we'll be alright. you'll quickly see this won't work. If I do 4, 1 times 4 is 4, add, multiply, that won't work. So you bring this down. 1 times 4 is 4, add. 1 times 4 is 4, add. 1 times 6 is 6, add. How do I know it didn't work? Because this is not 0, so it didn't go in evenly. Let's try negative 1. So here's how synthetic works. Bring that number down, multiply. Add, multiply. Add, multiply, add. So negative 1 didn't work either. So it could be 2. Let's see. So if we try it again with 2.
What are we trying to do?
So here's what we're trying to do. If this would have worked, that would have meant that x minus 1 went into it. Because 1 would be a 0 from x minus 1. So if this would have worked, that means that x minus 1 goes into this. So synthetic division is a very powerful tool to help factor things we can't factor otherwise. Okay. So if we try 2, let's see. Actually, let's try negative 2. Let's see what happens. 4, negative 8, 16. Okay, that's not going to work, right? If we try positive 2, 4, 8, again, that's not going to work. So I'll bet you anything is that last dude, 1/2. Every time I'm doing this, I'm doing the same thing. I'm just using different possible numbers that match up with what it could be from the problem. So 4, half of 4 is 2. Add half of 2 is 1. Add, that doesn't quite work, so maybe negative 1/2. 4 times negative 1/2 is negative 2. Add, multiply, that is positive 1. Add, no, that doesn't work either. Alright, so I made an evil problem. I was wondering if past Jeff made an evil problem. So this guy, it probably has disgusting answers. You'd have to get it from like Desmos. Yeah, unfortunately. Yes?
Can you factor with, two, like, I take it before we do it, like, 2x squared plus 1 into x minus 2 and take another 2x squared plus 1 and see if that fits the quadratic equation.
Say it again.
Like, we got 2x cubed plus x minus 2. If we can get,
2x cubed, what?
isn't that,
2x cubed plus x minus 2, sure.
right, and then we can do x into 2x squared plus 1 minus 2, and then factor 2x squared plus 1 into another factor, and
Right.
it's a quadratic equation.
So if I have 2x cubed plus x minus 2 equals 0. So go at me again.
X. We take x out of the first two,
X out of the first 2.
2x squared plus minus 2. And then if we can take 2x squared plus 1 out, and then, like, and add it to the other one and see if that's a correct equation. Does that make sense?
No, there's no legal way to do that. Move this over to here.
No, take it out, and then we have to add it together.
So would it be
Take it out.
2x squared plus 1 out, and then be x into minus 4x squared minus 2. And I don't know if that is x squared.
You
plus
can't
x,
take this out because this doesn't have one of them. So I'm not sure.
But we add. We can't take.
No. If you divide this out, you have to multiply it to
Right,
counterbalance it. You can't add and subtract it if you're dividing.
Yeah, if you multiply, then it'll be like a x squared. What's it?
So here, let me show you. So this problem, I just made one that didn't factor, that's too bad. But, let's see, what I get here was, 2x cubed plus x minus 2. Swinging in the right place, yeah. So it looks like it's 0.835, makes it 0. You guys see that? 0.835. So let me show you what's happening. So let me write that down. 0.835. Okay, so on a problem in the book, you're gonna end up with something that is actually factorable, which is always nice. But here, let's graph, what was the function from the beginning? It was, x squared minus 1, okay. And then I have the point. Can this thing do this? Let me see if we can do this. What was it, 2, -1? Ooh, look at that. Ooh, nice. And I want to know, so if I do, all right, let me see. If I do the point 0.835, no, Jeff, get out of there. All right, here we go. 0.835 comma 0.835 squared minus 1. That'll be the point that's on the parabola. If I have an input, I have 2 commas there for some reason. I can put it, it's supposed to be decimal, I can put it into the function and get the output. So that's going to be point on the parabola. Let me put a point there. There we go, see right there? So this distance, and just visually it kind of makes sense, this is the closest I could be to that point. Let's see, oh, I could do this, right?
Isn't there a distance button on our calculator to find the distance between?
Say again?
Is there like a distance button on our calculator?
Distance button on your calculator. No. It's too bad. Okay, anyway, so as I swing around this parabola, at this point, I would be the closest to this. I like it. So if this is something that's a meter in radiation, and we're the Earth on our little orbit, we don't want to get too close to that, possibly, whatever the situation is. Okay. So the idea with this section, you're going to see some problems that involve distance between functions and points. So pretty much when you get a problem, let me see if I can find one in the book real quick, just to give you one that actually factors. And then we're going to do Newton's method. Yeah, I think we'll be at time for that.
So we can't continue 2a.
Here we go. Say again.
So we can continue 2a because it doesn't factor.
Well, we got the answer, but we had to get it from Desmos, yeah, which is not satisfactory. Let's see if they have one that's not too evil. I think they're up here. Let's see if I can find one quickly. Probably not. But here, let's do this instead. Somewhere in here, if I find one, we'll look at it. Yes.
So if you synthetically divide by 0.832, you would get 0.
0.835, yeah.
Okay.
Which, is a little much to ask somebody to try to do. You can see some that are pretty straightforward. These are like the ones we did a minute ago. This one's actually easier than the cost one, because it's just straight up. We already know the answer here. That's the funny thing. So if I assign number 7, you have to do the calculus, but does anyone know the answer here? If I have all 4 sides, what shape will maximize the area?
Square.
Square. So if the perimeter is 100 meters, how long is each side? 25, yeah. So it's 25 by 25. So you already know the answer, but you still got to do the calculus. You guys all with me? It's only if it's against the river, so I don't need, or if I make it against my house, so I don't need that fence there. It's not going to be a perfect square. It's going to be some kind of rectangle. Okay. Then you have some problems like, here's a good one. There's an example of what's going on. So he's got a river and he's doing it at an angle. Thankfully, they gave you the picture, so you don't have to try to figure out how to draw this yourself. Here's one kind of like what we did earlier. I'm using this much material, so what is that relative to the shape that I'm going to end up with?
Rectangle.
Surface area. Perimeter is 2D, surface area is 3D. So they both are like going all the way around a shape, but one is 3-dimensional, so that's surface area. If it's 2-dimensional, that's perimeter, yeah. Yeah, okay, I like it. See how it has an open top? So that's gonna change your formula a little bit.
3Y.
I don't know if I'm gonna run up against one of his point problems, let's see. Oh, these kind of problems are nifty. Find the area of the largest rectangle that can be inscribed in the ellipse. Okay, what does inscribed mean? Does anyone know?
Put inside.
Yeah, so if I have an ellipse and I want to inscribe a rectangle in it, it would be like this. So all of its corners have to hit the ellipse. That's inscribed, right? To the best of my drawing capability, by the way, but you guys get the idea. If I want to inscribe a circle inside of an equilateral triangle, then the sides of the circle have to hit the edges like that. Okay. So you'll see that word inscribed in a few different problems. So the main idea with 4-7, the hardest step in 4-7 is going to be creating the function. It always is the hardest step. Well, once you get the function, it's just taking derivatives, setting it equal to 0. Okay. All right. So, last thing I want to do today, I think it's all I'm going to have time for. So you got to get to section 4-7. You got to try some of this out. I highly suggest anybody to start doing that tonight. If there's any old homework you haven't done yet, let go of it for the moment. You want to get into new stuff right away. And come ready with questions tomorrow. So, are you guys aware that your calculator, I don't think we've done this yet, but your calculator can find the intersection of two functions?
Yeah.
So everybody do this, let's see. Put in here natural log of x, if you have a calculator. If you want to play along, you can borrow one, I've got some. And put in here sine x. Okay, so we got two functions, natural log of x and sine x. I'm curious where they meet. I want to see where they intersect. I do want to make sure that I'm in radians. I am, good. So if I hit zoom 6 to make a standard window, so we're all on the same page, can you guys all see the answer?
Like about 2.1 or something?
Yeah, you can guess at it. Now, if I hit zoom box, one of my favorite little dudes, I'm going to go up and over a little bit. I'm going to make a box, enter, that's one corner, and then I can move down and over, enter, that's the other corner. So now I can see a lot better where they meet. Bam! All right. Does anyone know how to make a calculator tell me the freaking answer?
Trace.
Calculate intersection.
Oh, second.
Yeah, trace is not good enough. Trace will take big steps. Look at that. Every time I move, I'm taking a big ass step.
Second trace.
So when it's second trace, it's going to be very obvious which one you want here. Because I'm trying to find out where two things intersect. So on number 5. So let's see what they asked me. Has anybody ever done this before? Okay. So it asked me for the first curve. Am I on one of the curves? I'm going to hit enter. Look what it does. It bounced to the other. Now am I on the second curve? Yes. Hit enter. Now it wants a guess. So go over here. Enter. And then it tells me. Now, real quick. I know the calculator can do this. What we're about to do is we're about to do the work to figure out how the hell the calculator does that. You with me? We didn't just find this laying on the ground somewhere and it's got magic in it and we're like, oh, let's make a calculator out of this thing. We actually had to program this based on calculus so it could figure this out for us. So we're going to talk about what algorithm does the calculator use to figure this out. So if I'm given two functions, and actually let me say this, if I'm given one function is natural log of x and the other function is sine x, and I wanna know where they meet. Do you all agree that's the same thing as solving this equation? Right? Okay. Let me make sure. I'm gonna use the same notation these guys do. Blah, 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 blah. Yeah, okay. So doesn't this amount to, if we call this f of x, doesn't this amount to finding the x-intercept of this function? So if I'm given two functions and I want to know where they meet, I can define a function to be the difference of those two, and I want to find the x-intercept of that function. Are you guys all with me? So the way we're going to do this is kind of nifty. So let's say I'm given a function, and I want to find the x-intercept. So here's the function. Yeehaw. So I want to find out this x-intercept. It's two of them. Let's say I want to focus on this one. If I guess at the intercept, let's say our first guess is x0. So part of this process, and that's why the calculator asks for a guess, this process depends on your guess being good, being decent. If you just feed it like 1,000, it's going to freak out. If I would have done that, I should do that on the calculator. If I give it a really bad guess, it'll sometimes come back with an error. Like, I don't know. And in this process, you're going to see why. Do y'all agree that my guess is pretty close to the actual intercept?
Yeah.
Especially because the function's pretty smooth. It's not going crazy, right? So the idea of close we talked about before. Here, the function's pretty good. So that's pretty good. That's pretty close. Okay. Could I, now watch this is so stupid cool. Couldn't I calculate the tangent line here? Yes? We've done that to death. We know how to calculate tangent lines. Doesn't that have its own x-intercept? Now, from my picture it sucks, but if I would have drawn this a little bit better, this would be closer to the actual answer. If I do that again, if I construct a tangent line, do you see how its intercept is like almost right on the answer? So what the calculator does is it does it does this, but I'm gonna show you how it makes an algorithm out of it, and it just kind of keeps doing that. It takes our guess and it works out the next intercept from the tangent line, and then it makes a new tangent line, works out that x-intercept, and it keeps going until it gets to within close enough. Okay. So that first step. So let me do this again. So I got my function, looks like this, and I want to know this intercept. When I give it a guess, and I want to calculate the tangent line. So I got the function, I've got my guess, and I want to know the tangent line at that point. What do I need to know to get the tangent line? You know the point? Good. So what is the point? X0? It's not a point, it's a number. F of x0, yeah, I mean, come on. If I know the input, I just put it in to get the output, right? If I know the x, I plug it in to get the y. There's nothing to, if I have a point, an input, at which I want to get a tangent line, I need another point, which means I got to plug it in to get the output. What else do I need? Slope. Or like somebody's whispering to me, slope. What's the slope related to? The derivative at Nothing different. This is actually just kind of like how you find the tangent line. This is kind of capturing the idea. This is what we do every time. Can somebody put that tangent line together for me? Yes, y minus, good, f of x not, equals, m is times x minus x not, okay. By the way, let me make sure, we are in the middle of a derivation. You're not gonna have to do every step here. We're gonna get to a point and say, this is the thing we're gonna use. Y'all with me? We are deriving the process that we're gonna use. You're not gonna do this every damn time. Now, real quick, I've constructed the tangent line there, yeah? In fact, if I could just do it better, that'd be great. I've constructed the tangent line through that point, yes? And now I wanna figure out its intercept. Its x-intercept, yes? How do I calculate its x-intercept? Whenever I want the x-intercept, I make y0, yeah? So here's math in a nutshell. I don't care how ugly the thing is I'm looking at, how do you find the x-intercept? You make y0. It doesn't matter what the thing looks like. And I know that looks kind of funny, it looks worse than I wanted. There's no numbers in there. I don't care. I want to know the x-intercept. So I make y0 and then I solve for x. Alright, so if I make y0, I get this. How do I solve for x? I'll give you a nice first thing. You don't have to distribute this thing. You can just divide by it. Is that cool? If I divide by f prime. Yeah? Why is that good? What do I do now to get x by itself? How do I get x by itself? Add x0, yeah. So I get x equals x0 minus f of x0 over f prime of x0. And I love you guys. You're all thinking this is something brand new. This is old shit. This is old. We know how to construct a tangent line. We do. There it is. And that's exactly y minus y1 equals m times x minus x1. Nothing new there. Nothing new. We know how to find the y-intercept of any line, any function. We make y0. And we solve for x. Is this pretty? Is this what you wish it was? Are there numbers? No, no, and no. But the process doesn't give a shit. And this is real. It's not hard to solve for x. Not difficult to solve for x. I solve for x, and I get this thing, and I know in your head you are not liking this, but who cares? I just plug shit in. This is now a process I can use. This is now going to be my next guess. And then I'm going to do the whole process again. So this would be my next guess. And every time I do this, I get closer and closer and closer. If my first guess was good. So here's the idea. If I keep doing this, I'm going to end up here. My next best guess is going to be the guess before, plugged into all this stuff. So if n is 0, I get this here, don't I? Right, I get this here. If n is 0, I get this. If n is 0, what's this? 1. Okay, so if I want the third guess, that would depend on what the second guess was. Yes?
Sorry, I missed that step. You said x to 1? What?
All I did was I solved for x, right? I solved this for x. Is that cool?
Oh.
Add the xo, so x equals this business. I just wrote it this way.
And that's now x.
Oh, okay.
And now I call that my next guess, x1. And then the next guess after this would be x2. So x2 would equal x1 minus f of x1 divided by f prime of x1. x3 would equal x2 minus blah, 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 blah. Yeah.
I don't understand how taking all these x-intercepts gets you closer to the x.
So watch this. So when I do this, I get another guess. Then I find its tangent line. Do you agree with me that x-intercept is closer? Then I take its tangent line, and then every time I do it, as long as my first guess was close enough, I'm gonna keep getting closer and closer to the actual answer if I keep doing this over and over. If my first guess would have been here, tangent line. What's the tangent line's x-intercept? Isn't it way back here? If my first guess was here, do you see how my second guess is further away? Because my first guess sucked. Now what is really weird is what if my first guess is here? What's the slope? So where's the x-intercept? None. That's where the calculator would freak out. If your guess is right on a hump, it tries to do the thing. It's like, error, I can't do that. So again, this is such a beautiful idea. I'm going to try it again. If I have a function and I want to know the intercept, if I give it a guess and I construct a tangent line through there, the x-intercept will be closer if it's a good guess. If I go, my guess is too far away, my tangent line could go crazy and take me way off. This is why you want your guess to be close. And so now my next guess is this here. So if I construct a tangent line for it, now my x2 would be really close. So as long as my guess is good, and I let this process carry out a few times, every time it's going to get closer. The calculator has a certain error tolerance, where once its guesses stop changing so much, it stops. It says that's the answer. And that's why sometimes its answer is 3.999999999 when it's supposed to be 4, because it just stops when it's within the error tolerance. I contacted TI and I wanted to know, hey, can you tell me how you modified this? Because it's a modified algorithm. It's not exactly this. They modified it a bit. And they were like, are you from HP? Are you trying to get no, we're not going to tell you shit. I'm like, damn it. So they wouldn't tell me how they modified their program, but I know you're all beat up about that. So let's do an actual frickin' example. How's that sound? So what if I want to know, let's see, where x squared equals, sure, we'll do science. Does anyone remember the first step? How to identify the function I'm going to use?
On the guess point.
Not yet. Nope. Nope.
X squared is x.
Say again, sir.
X is x squared and gx sin.
No. Come on. I subtract sine x. Now it becomes a question about where's this guy's x-intercept, right? So this is the function that I'm using. Okay. So what is f prime?
2x.
I like. Now, if we draw a really rough sketch, right? So like if I do, let's see if you guys are cool with this. This is 1, and this is 2. Pi over 2 is like right here, so about 1.57. X squared, is that cool for x squared, right? So there's x squared, yes? Sine x, yes?
What's that red underneath the x squared under sign?
Sorry?
What's underneath your sign for the x squared?
Here?
Yeah.
It's just, I'm identifying what f of x is, yeah.
Oh, okay.
Okay, so now I've changed the question from where did these two functions intersect? I've changed it to what is this function's x-intercept? You guys see that? If I just subtract that side, now the question becomes find the x-intercept of this function. Is everybody with me on this so far? Okay. Let's say I'm only interested in the positive side, just to make this a little easier. At pi over 2, where's sine? No, come on. At pi over 2, where's sine? 1. So doesn't it go like this? Sign goes like that, yeah? Blah, 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 blah. So what's a good guess for their intersection would be 1. It looks like it's really close to 1, yeah? So if you draw a rough sketch, you can kind of tell what's a good first guess. The better your first guess, the quicker the process will be. The worse your first guess, it might not even work. Okay. So how's this work? I know that xn plus 1 equals xn minus f prime of xn divided by f of xn. Is this the same thing I used before? Oh yeah, other way around, sorry. Prime on the bottom.
We just got that formula from what we did previously.
Yes, cool. So I'm going to give you this formula. You just have to know how to use it. So if I want to know what my second guess is, what do we say our first guess is? 1. Okay, so we're going to make our first guess 1. So our next guess will be 1 minus f of 1 divided by f prime of 1. So I'm going to do this manually with you, but then I'm going to show you a beautiful shortcut to do in the calculator to make it do all the work itself. But let's just do this manually for once. What is f of 1? 1 minus sine 1, yeah? I didn't pick the best function, but I will. 1 minus sine 1. And what's f prime of 1? 2 minus cosine 1. I love it. Okay. So this x, our next guess will be 1 minus sine 1 divided by 2 minus cosine 1. So if we plug that in an old calculator, one minus parentheses 1 minus sine 1 divided by 2 minus cosine 1. I get 0.576. So that is a improvement on our first guess. Then I could do this whole thing again, but I would put 0.576 here, here, and here, right? You guys kind of with me? Don't you wish there was a way to automate this so I don't have to do it every single time? Okay, here it comes. This idea, though, it kind of bums me out that you don't see the beauty of this, but this idea that if I have a guess and I construct a tangent line, I find its intercept that's closer, then I do that again. I construct a tangent line, find its intercept that's closer, then I do that again. Every time I do it, I'm going to hone in on the right answer. And I just tell my calculator, hey, when you're so close, you can stop, because otherwise it's going to go forever. Right? It just won't stop. And I'm like, calculator, what the shit? Okay. So here's how to automate this. Here's what I like to write. Okay. If I take this, and let me show you one thing. Yeah. What if I had to? Everybody do this with me if you have a calculator. Do 0.9 divided by 77. Now, let's say I want to take the square root of that, and I don't feel like writing all those digits. We've talked about this before, but does anyone remember I could do the square root of answer? This button is what's going to make Newton's method stupid quick. It just takes the last thing that was on the screen and plugs it into this function. So I don't have to write all the digits. So here's how I write this. I write, this will be our guess. So let's see, let me see. I hit my guess, so let's do this. I want to set this up first. How do I want to do this? I'm going to say guess minus f answer divided by f prime answer. So, yeah. In this case, it would be guess minus F was x squared minus, so it'd be answer squared minus sine answer. So I'm plugging answer into this. All over f prime, which would be 2 answer minus cosine answer. Okay, just go with me for a second. Watch this. This is cool. In fact, guess, let me put an answer here. Okay, so here's what happens. If I write my guess, everybody hit 1 on your calculator if you want to play along. If you don't have a calculator, it's a really good time to go. Hit 1. Now, answer has 1 in it. Answer is it's always the last number that showed up on the screen. So if I just plug in here, answer, right? Second negative for answer, minus, exactly what I got here. Answer squared, second answer squared, minus sine of answer. Let me stop for a minute. So I've just put answer minus, answer squared minus sine answer. I put that on the top. Divided by, parenthesis, 2 answer minus cosine answer. So when it does that, when I hit enter, it's going to use 1 for answer, correct?
Yeah.
And then there's going to be a new number on the screen. It's going to be the number, is that what we got? Did I plug this in right? I love it. Let me make sure I got all this in there right. Answer minus answer squared minus sine answer. Yep. Divided by 2 answer minus cosine answer. Okay. I might have done something. Oh, of course. Okay. Now it's different because now this is answer. So it's going to, if you hit enter again, it's going to recalculate the whole thing, but now it's going to use the second guess. This right here is the second guess. Are you with me? 1 was our first guess. We put a 1, we hit enter. Now I plug this in, it's going to calculate all of this with a 1 in it. Now if I hit enter again, it's going to recalculate the last thing it did, but now with this number in. If I just keep hitting enter, I'm going to eventually get something that's not changing anymore. That's the answer. So if we go back, don't worry, I think I already gave you the handout. It's on the back of one of my handouts. Let me see which one it was. Blah, 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 blah.
The word problem.
Yeah, on the back of the word problem handout, there's Newton's method. So I've got it there for you, right? So real quick, did I have these functions in here? I did. Did we do this earlier? Did we calculate this earlier?
No.
We didn't? We didn't get that intersect? I thought we did.
Yeah,
And we got, where'd it go? Oh wait, was this the same? No, this is not the same. This was different. Let me put this in here, x squared. Let me put this function. All right, so I'm going to do these two functions, x squared and sine x, yes? All right, let's see where those intersect. There's x squared, there's sine x. So I'm going to do this intersection here. Here's a shortcut for using intersection. We're going too far. Yeah, we're going too far away. It's coming. There it is. Put the cursor right on the answer, enter. Isn't that what we just got? Yes? 8767 blah blah blah? Yes? Okay. I love you guys so much. So the handout I gave you earlier has examples of this on it. And what have I done with, here we go. Yeah, so on the back of the word problems handout, it's got a couple of examples worked out for you. So it's got the general form of Newton's method here, and then it's got the specifics for this problem I'm looking at. All right? So if you just hitting enter, you're gonna get to a point where nothing changes, and that's where you know you can stop. The better your first guess is, I think this is exactly the one we did earlier. Enter. You keep going until the numbers don't change anymore, then you know that you've zoned in on it enough. Okay. And you can always check your answer by just doing it in the calculator and making the intersect process. Okay. Alright. That was only a little painful. So I'll see you guys tomorrow. We'll finish up chapter 4. We'll definitely get into chapter 5. And we'll talk about when the next quiz might be. Yeah.
You say you don't know what the next quiz is yet?
No idea. Yeah.